Great, and thank you so much. It's 3 p.m. We'd just like to start now. Firstly, welcome to Trend Networks, a webinar, Copper 4. It's just hit 3 p.m. and we really appreciate those that could join us today. Let's take a dive into PoE, and please join me today. Okay, so I'm just gonna get this started. Right. And welcome to Trend Networks Academy, your knowledge partner for data network technicians and network maintenance professionals. Of course, everyone's welcome to join us on these webinars. The whole thing here is sharing experience, sharing education. However, we really would like feedback from the marketplace. So this is a part of a shared knowledge journey. Our solutions provide proof of performance. We remove the guesswork when installing and maintaining commercial network systems. And my name's Gordon White. I'm here to help you with this journey. Let's go. So data networks need to be reliable and uptime is critical. Network technicians need to be ready to address, do you have enough PoE? It's a strap line, but it's real. Hidden behind a lot of these networks today is they're powered by the same data cable. And again, welcome to Trend Networks. Welcome to our learning journey. This is an update, PoE 2024. Okay, so in this update, certainly no fancy AI generated slides. This is us helping you with knowledge. We want to walk through what we see from the field, real feedback. I will attempt to even put a poor joke at the end of this slide, so do bear with me, but let's get started. It's an update. We will talk about where we are, modern PoE, 90 watt, and a two-step testing method intended to help you. Let's have a look. So firstly, as we know, power over Ethernet, fondly known as PoE technology, continues to be popular. It started with VoIP phones, cameras, Wi-Fi, and it's emerging into IP lighting systems and access control systems. We use PoE technology every day, and it's deployed almost everywhere. If we look back, PoE as a technology combines power and data. So that's a combination of power and data, originally developed by Cisco. Yes, those guys, we have to be nice to Cisco, back in the 2000s for IP phones. It quickly became successful to save time, space, and deploy phones and other devices. So it's a combination of power and data. PoE is deployed in two common methods commercially. Typically, a PoE or a switch, which is a combination of data and PoE, data and power, and then the device at the end. Or it may just be a standard data network switch where you can add an injector. So let me just get a pointer on that to help us through this slide. So this is an injector, and we're talking about a network switch and the option to add an injector anywhere in the system. So if we do design a system, it's quite clever to have a combination switch where we can consolidate our PoE and power in one area. However, the pitfall here is we need to know our budget. That switch will be budget limited. So there are options to consider as we go forward. Okay, this is not intended to talk about standards and bore you to death, but please bear with me. It is important to see where we came from. So 203, 209, PoE 2 pair really was in development. And well done to standards boards and all those fantastic manufacturers out there that really put concepts and designs out there. However, people may not be aware we had to solve a lot of problems. Firstly, there was different power patterns on the wire map, different configurations. There was no common method for device detection. There was sometimes no device protection. You could burn a device out. And the maximum power draw varied across devices, across systems. So with standards came some definition, and they had solved the problems, and two-pair PoE continues to grow. So we need these standards, and the key message or the key takeaway here is progression. We now started to, as we stabilize two-pair PoE, we see two-pair typically deployed everywhere today in the office environment. In fact, people don't even think about it, it's so reliable. Yet, I must bring your attention today, which is a part of this refresher, is that some cable manufacturers started to talk about lengths around 80 meters already, even though two-pair is so stable. They started to bring up some of these issues around PoE. So let's understand why. Let's take a deeper dive. We moved the two-pair as we moved upwards. Two-pair and standards developed. We had the TIA now, as an update, requires resistance unbalanced testing on every cable, okay, as a mandatory requirement. The ISO 14763-2 recommends a PoE budget. It addresses it differently to ask you to do a PoE balance, but ultimately they're concerned about length, okay? So in many ways, the progression of PoE was getting ready for four-pair deployment. So where we are now at a four-pair environment. PoE four-pair has been deployed since 2018, and these are some of the challenges we currently have. So thank you so much for those which are working in this industry, working on these systems. They're fantastic, they're working very well, but these are some of the challenges we have to face. And it's resistance in the cables and connectors, which installation and termination is quality critical now. There's also heat management in bundles, which many of us are aware, and also the environmental impact. Some people are working in hotter countries, and that will affect our cables. A cable certifier is required to achieve and to test in these parameters. And once again, it was the IEEE definition of the standard which helped us see and develop some of these requirements to meet the deployment of four-pair. Okay, so you can see here that we are at four-pair. Now the question would be, typically with standards, who's using it? Four-pair is pretty much in use now and growing in popularity. However, it would make sense that people aren't just deploying high-powered systems for the sake of high power. Now, the idea was to engage the ability to do more with what we currently have in that system. So the latest four-pair standard, the 802.3BT standard that's been out since 2018, allows 60 watt up to 90 watt to allow more functionality. And some of those functionalities are very quickly seen in pan, tilt, zoom cameras, TV displays, and LED lighting systems. There's of course more to come. It's just opening up the market for control devices. Four-pair PoE deployment does now require greater focus on length. It is susceptible to higher environmental temperature challenges. We need to be aware of these things. So please do stay with me, because we're going to show you a two-step test method that we can address all of this. But once again, I'd like to create that vision in your mind that this is now a four-pair system, okay? So what do we know? We know that current feedback from the field, that's what we've seen from working with end users and cable specialists, is that they're seeing immediately lengths are affected. So that means when you're deploying four-pair PoE, you need to consider your design. So typically even two-pair could be as 80 meters would be an idea for best reliability. Now 65 meters in the maximum in warm countries for best reliability. This is now getting quite serious. So I hope that's quite a helpful hint on where I'm going with this, that this is a serious consideration. And of course, you'd need test tools, and we would like to help you with that as well. Okay, so I'd like to introduce what we're finding as best methods, best practice to solve some of these challenges. It will be a two-part test method, and firstly, we'd like to consider the components. So part one is the component level testing. And that has been highlighted with a recent change in the TIA, moving to adding resistance unbalance as a minimum requirement for all cable tests. Okay, so part one, cabling and components. We'd also recommend timestamp reporting across any tester that you use. So part one, the importance here is, as you can see, we've got our technician looking very smart in blue. The idea is to introduce you to the concept of what is resistance unbalance. I hope to go through and cover that today. So at the component level, the cable and component level, we are addressing reliability of our PoE system. So resistance unbalance is now defined in the TIA and 14763-2, okay? How it works for TIA, they want that on every test. It is now mandatory. So please be aware, you now need to have that in your testing. For 14763-2, it recommends a link budget calculation where register for PoE 1, 2, or 3 can be calculated via a budget. A very interesting approach. Ultimately, we're looking at each pair and how they compare to each other. Let's look at it in a bit more detail. Here are some of the challenges when we do a component level testing. These are some of the things to talk about when we troubleshoot before we look at exactly what the resistance unbalance is. So when we're looking at troubleshooting at a component level, first of all, we'll need a special tester. And over here is a certifier. So certifiers, for those which are not familiar with them, are a special tester which is able to do electrical frequency-based testing. And the idea is it does a test to cover multiple applications, including PoE. And it is only a certifier that can do that. So I just want to confirm a certifier is needed in the latest test requirements. Okay, so step one for troubleshooting is, of course, to certify the link. And we're going to look at all the elements, the cable and the connectors, okay? And of course, you would need to fix these elements, cable connectors, wire maps, and we use terminology such as near and crosstalk, RL faults, all those things when we talk certification. The new addition is this resistance unbalanced. We'll see that in a moment. It also needs to be noted that anyone with the trend team, anyone a part of our trend team that's joined us and purchased a Lantec 4, we always test for resistance unbalance regardless of tests. In fact, many of those which have been using a Lantec 4 in the past, worth knowing, it's always collected your resistance unbalance. So those which are now meeting the latest standard, you can go back and recertify links and grab that PoE data. That's there, that's in the Lantec. So no time penalty, 7-second test time, you get that resistance unbalance. I need to just help, this is intended to be helpful, a warning, anyone using other testers, you need to ensure DCRU is turned on. Make sure you select that as a part of your test, otherwise no data is collected, okay? If a DCRU problem occurs, you do need to view your connections first. You would use a TDR next to look for frequency pinch points, and of course RL if you're looking along the cable, but typically TD next you would use to discover it. However, in some cases, it's not the termination, not the point of connection. In some cases, it's not just even a dirty connector. It could lead to actually being a poor cable type. So if you believe your cable type is suspect, and we do see that in some rare cases where copper-clad aluminium has been used, that was intended for short links. Please try to avoid that type of product deployment. It's fine on a very short link, but to be honest, it's not a data cable. It's not rated as a data cable and definitely not designed to carry PoE. So do be aware that's a pitfall there. Insertion loss, another tip that you may come across, may fail. And sometimes we see that above 80 meters. And again, that's a sign that the product wasn't quite really designed for PoE. Okay, and that may happen. Mostly due to length, you will need to reduce that. And some manufacturers now are starting, well, they do already provide PO-ready cables. Of course, lastly, and I've left this to last, is the biggest challenge is PoE on patch cords. Typically, patch cords are rarely PoE rated. In fact, that's the last thing they think of in a design, and they pose the biggest performance problem and biggest degradation. Always seek PoE rated product where possible. And the reason for that is new, and you can see that on vendor labels. Okay, so let's have a look a bit more. What is this resistance unbalance? I tried to look at it from a different angle, and I hope this is interesting for you rather than talking electrics. I'd like you to maybe consider the image on the screen that firstly, DCRU is the comparison of the readings between each pair. And an idea is that no pairs, you may not be aware of this, that the pairs are not all twisted the same. Maybe some cable vendors might do that, but typically not all the same. And in many cases, the blue pair, because it's centered in the middle of the plug, is twisted the most. So blue as pair 4 and 5 is typically twisted at a higher rate, orange a little less, green a little less, and then brown the least. So we have a comparison between blue and brown could be quite big. And if you think about that as material, there could be a lot more material in blue versus the brown. So this is a challenge. And to mitigate these challenges, cable manufacturers are now starting to develop PoE rated patch cords and cables, PoE rated products. So it's a comparison between the two. More material in blue could cause a higher resistance, or a comparison between the brown, imbalancing the system, okay? So what do they find as you start having a higher resistance with cables in general across the pairs? Vendors, and this particular guide from Molex, noted that heat was added into the cable. So just slightly on the note of a higher resistance, I want to share that vendors discovered that bundles are slightly heating up. So they were hinting that you need to get air. You need to get air to some of these cables, and most particularly in warm countries. So if you're in a warmer country, this is your challenge. Okay, so how to get air to those bundles? Well, it's not in all cases, but it needs to be noted that they do heat up. Okay, so the idea is what goes wrong? What goes wrong if you have a pair imbalance, if you have a poor connection, or heat is getting too hot? Here's our reliability issue. Basically, PoE is designed to be very, very safe. It has an inbuilt safety balance, a cutoff. And so the idea is not to cause fire, and well done to the designers, by the way. We have not seen fires on PoE, well, not that I know of. And it's due to this issue that once it sees an imbalance across those pairs, that balance will switch off to try and protect itself, affecting your reliability, affecting your performance, affecting your data stream, your link. So if you'd like reliability, hence resistance DCRU is now important on every single test. Okay, so in summary, this is very noticeable in warmer climates. Just again, okay, DCRU is needed, is necessary, and warning, temperatures above 40 C is a quick shortcut. There's no more 90 meters. Reliability really starts around 65 to 70 meters max, 75 meters max. So I hope that helps. That's a key tip for those in warmer countries. Okay, so temperature derating. Okay, so just to sum up there, we're now leaving the components, and we're now saying that it was so important to think about our components, to get the DCRU, the balance right, and that is via a certifier, a must do on a certifier. I'd now like to think about the power delivery, power to that system. So separate to that is the device actually sending that power through that system. That could be the switch, or that could be a PoE injected, added anywhere in that system. So part two is the power delivery. Okay, and of course now, here's where we also talk about standards and what the IEEE did up to 802.bt. Okay, so you need a separate device for part 2. When we look at the troubleshooting, when we're looking at power delivery, it's really, really important to be aware that not all testers are the same. Okay, the majority of testers available today, just look at the feed. They're not actually doing a load test. So I just want to confirm what I'm saying here is that we've got standards and we also need to measure against them. Can you actually give me enough power? What about the draw under a load? A simulation as if a PTZ camera is moving or unless that device is actually operating. So this is what this product is doing. So you need a product which will give you a load test, a draw test. So PoE Pro does a power load test against a standard. It's just a brief load test to simulate, is that enough to meet that standard from AT-AF, which are the 2-pair standards, to BT, to apply a pass-fail. Okay, so be aware there's standards and be aware there's the need for a load. Number 2 is, so if we're looking at troubleshooting for PoE delivery, or sorry, power delivery, first step is test the link for length. Length is critical. And certify, we've got to make sure it's balanced. Number 2 is the patch cords. They're rarely PoE rated, so do have a look. Warning, again, another tip. Be aware, there's lovely mini patch cords. I absolutely love them, but they can be your undoing. 28 AWG or 30 AWG, basically the thin stuff that looks amazing, really, really struggles when it comes to PoE, subject to length, subject to how long your link is. Be aware of that, and especially at 90 watt, okay? And lastly, number 3, check your switch budget. So overall, if you're thinking about your switch, it could be as simple as saying, I've got a 60 watt, I've got a 24 port switch, it's 60 watts, times that by 24, come up with a number and check its maximum load rating. So now that we have those 3 criteria in place, again, you can see that it was important to check the design around that system. We now need to go to the tough part, using the standard to say, have we got enough PoE? So here's a device, the Trend Networks PoE Pro is a device which covers all of those challenges for you, very, very simply. It will run a brief load test against the standards which pass-fail, a very simple wire map, maybe it's broken, okay, to detect distance to fault, power at the source, it will test the feed at the source, very interesting, we'll get there in a moment. The type of power at the source, it's sort of interesting as well, and pass-fail against that standards. Wait till you see the standards on the next screen. This is quite a lot of detail, but pass-fail against those standards, we're going to take that pain away for you, okay? And of course, very interestingly, some people have to go outside of the standards. We totally understand that. If you're deploying a security camera into a car park, what to do? Very, very hard. So you could potentially use this. You understand reliability will be affected, but you could have a look at power at the end device, regardless of length. And if you'd like to know more about that, please do join us again, because we can talk about that in future. But let's look at this standard right now. So I'd like to introduce the 802.BC standard. The first thing we need to see is this is a very, very important addition. We're just going to highlight it's adding the 4-pair. So on the left-hand side, where my highlighter is a series of classes 0 to 8. Very, very helpful. They're starting to break down a system where people build devices, and typically a lot of manufacturers are very, very clever. They're trying to keep their devices in this low power feed, this low power mode, to aid economical use of equipment, okay? So the next step is, I hope you've noticed that there's 2 types of numbers here. Let's have a look at them. So we have a high setting on this particular product for demand at the power source. You can imagine if you put a source device there, what are we going to get out of that source directly? This is important if you're measuring a switch or you're measuring a PoE injector. So PoE Pro can have a look at that switch and say, have we got enough as expected from the standard? But once we add cabling, depending on how long that cabling is, we're going to have a resistance imbalance there. We're going to have a resistance effect there, okay? And so we have a low setting option allowing you to say, okay, so what do we get at the end device? Example, if we're looking at the top end, we would expect 90 watts out of the switch, and to minimum operate that PoE 90 watt at 90 meters, we would expect 70 watt at the end. Okay, that's at minimum for that device to operate. Okay, not allowing for temperature derating and not allowing for heat. Okay, but that's how easy that would work. A tip can be that you could set this device, you could set PoE Pro to high. You could use high at the source device, and you could use a high setting at the end device, at the end of the cable, allowing you a little bit of margin. So that's a neat tip that could help you out to say, have I got a little bit extra in there to make sure I meet that? Of course, if it fails, you can always reset the device to low to see, are you getting just enough at the end device? So that is power draw testing using PoE Pro. Okay, this is my attended joke. I hope you're enjoying it so far, and I hope that's been helpful, some of those tips. We're here to help. The future, the PoE future is positively charged. We here from Trend Networks are really trying to take information from the field, share this to you, and come up with ways to help you do what you do better. So as you can see here, PoE technology is used everywhere it's deployed. It's deployed throughout various systems. The future is going to see PoE deployed into different areas. Right now, what they are working on in PoE is to reduce the power consumption for 90 watt. The idea is the consideration of green PoE. The idea is, if that port's not in use, can I turn that off? Can I turn that down? So right now is PoE is trying to go green. Okay, let's hope we get it there. And the next stages are looking positive. So this is a progressive technology. Please join us again. The futures are looking into smart building, LED lighting, information boards. Okay, so we hope you enjoyed that. I hope you enjoyed our first session from me anyway, from Gordon, with the Trend Networks team, the Trend Networks Academy. A bit about us. Our mission is to provide helpful solutions and empower you with connected testing systems. We have a culture here of pace, precision, and we want to partner with you. We really would appreciate your feedback on what's important to you. So thank you again. Thank you for joining us.